Okay, so first thing you need to do when you get this up is to turn on both over here in the view menu. You have density, temperature, or both, and show labels. The labels only shows crust and mantle. And right now, for the first part, you're only looking at oceanic crust and continental crust. We're not worried about the center section. And your first job is to determine the thickness, density, and temperature of the oceanic crust as compared to the continental crust. So since thickness is first, I take my ruler, put the top of it to the top, and measure what that thickness is. Then I come over to the continental crust and do that there and report those two numbers for oceanic and continental. Next, we're doing density. So the density thing, just make sure that that arrow is in the oceanic crust and then read what the gauge is. It's analog, so you have to actually count your way around. The dark marks are ones. So, that's 1, 2, 3, 4, 5 is up here at the top. And then over here, so you do it on both and record it. The temperature is the tricky one because the temperature is different at the bottom as compared to at the top. So I recommend that you measure the temperature at the top and separately at the bottom and record both of those in that box. So there we've just looked at some of the basic properties of the oceanic versus continental crust. Next, we're going to go ahead and answer the question, which property do you think causes the continental crust to have a higher elevation on average than the oceanic? So if you look at the continental crust, its elevation here is higher than the elevation of the oceanic crust. Oceanic is underwater, continental is above. So you need to explain why. And I'll give you the hint, it has to do with floating because these crusts are floating on the mantle. Now we're going to make our own crust. So now we're going to deal with the middle section. So for the middle section, we have what happens to the crust as you increase thickness. So I increase the thickness of my crust and you observe what happens. Does it float higher or lower? What happens to the top and what happens to the bottom? And then using this, you complete this statement by writing in continental or oceanic in each of these two blanks. So one word here, one word there. Next, we're going to change the composition. So just keep the thickness here somewhere in the middle and go from an iron composition to a silica composition and record what the difference is when you move between iron and silica. So you report here, does the oceanic crust have more iron or more silica? And does the oceanic crust have more iron? Continental crust have more iron and more silica. So what I recommend is over here to the right-hand side, you record what happens when you change the composition. So then underneath A and B, you can actually put in, this is what the oceanic has, and this is what the continental has based on what you saw changing. And then set the thickness and composition to the middle and write down what happened, what type of crust you have. So what type of crust would it be right now? Above water or below water is the key thing. Above water, continental, below water is oceanic. And then we're going to change the temperature. So you change the temperature and see what happens. Once again, record what happens when you cool and heat. This here, you're now filling in this table based on the answers that you just put in here for 3 through 7. So you really don't have to do anything new. You just have to summarize what you already wrote in your answers for 3 through 7. Then we go to this video of sea floor spreading. And between watching the video and reading the text under it, you have all the information you need to answer these questions. Next, we go to the plate motion portion. And once again, turn both on, show labels. And once you put continental crust up, or oceanic crust, then show seawater just so you can see it. So you can put this together however you like. Play with it a few times. Note we have the descriptions or definitions of what a convergent plate boundary is, a divergent plate boundary, and a transform boundary. And of course, what subduction is. Now, after you played around, then we're going to get serious. So set it up with a continental and an ocean crust. So here I have a continental and an ocean crust. It doesn't matter if it's young or old. I put young. And you have a green arrow. And so what type of boundary do we have if I make this slide in the direction of the green arrow? So you answer what type of boundary that is. And then you says, sketch a time series of the process. So what I recommend is oceanic, young ocean. Show these back. Write what it looks like before you start. And then write what it looks like after, like, let's say, okay, that's 8 million years. And then let her keep going and write, oh, that's supposed to be on both. Write what it looks like after 50 million years. So you just go through and you draw in pictures and make sure that your pictures show the direction of motion and which type of crust is which. And then it asks us some questions there. Now you're going to reset with 2 old ocean crusts. So reset all and 2 old ocean crusts. And once again, show both, show labels, show seawater. What type of boundary does the red indicate? Red, they're moving apart. What type does blue indicate? I know both arrows look like they're coming out, but they're going to be going, one's going to be going the direction shown, the other one's going to be stationary. And then you're going to show the red direction. So once again, you need 3 pictures. So one before it starts, one after it's gone a little bit, and one after it's gone, the 50 million years that it'll do. And then you answer one more question. Now we reset to the 2 continental crusts. Reset all. Continental, there's no water to turn on. Show seawater, but there's no water. It asks you what each of the 3 colors, green coming together, red moving apart, and blue sideways. And that's going to have us use the red arrow again. So again, the 3 pictures. So one to begin with, one about there, and one after a very long time. And now we're almost to the end. You see, this is the last page. You have to do 2 other scenarios. So for instance, one scenario would be I do it like this, but I'm going to pull it this way. So we have sliding in the blue direction and describe what happens, what type of boundary it is. Another option that I like is bring them together. There's no subduction now because you don't have an ocean plate and a continental plate. You have 2 continental plates coming together. And so we can see what happens there. Or, just as interesting, I'm going to put 2 oceanic plates and make those come together. One's old and one's young. You see, that did something. Try it with both of them being old. It won't let me bring them together if they're both old. Got that option. Let's try them both young and see if it'll let us bring that together. Nope. Okay, so you have to do 2 more, and then you have 2 final questions, and you're done. That is it for the lab. I hope that it works well for you, and I hope that this recording works well for you.